Okay, I want to jump right into, hopefully, what is our last day of lesson 2.1 and talk about the quadratic functions. Okay, so when I say quadratic, I'm talking about equations that have what in there? How do I identify a quadratic function? Has what? A square, right? X to the power of 2. So when we talk about our quadratic functions, parabola is based on y equals x squared. And we're going to do, I don't know, a little bit of everything with these parabolas today. So first thing, this kind of goes back to Algebra 2 and what I'm doing right now in Algebra 2. Describe how to transform the graph of f of x equals x squared into the graph of the given function. And sketch the graph by hand. So this goes into, okay, what are the different transformations we see? Okay, so A, g of x is negative 1/2 x squared plus 3. Let's start with the describe part of this. What are your thoughts? What are the pieces here? X squared is the basic function. Go back to your Algebra 2 days. In Algebra 2 we had a gold paper that had all the different pieces on them. What do some of these pieces tell me to do?
The plus 3 up 3?
Yeah. Plus 3, when you have a number added at the end, that's going to be a vertical translation. So it's going to take me up 3. Okay.
The parabola facing downwards and shrunk by half.
Okay, so the negative tells me it's going to, basically you got, Natalie just said, okay, it faces downwards, it opens down. Officially, it's a
I'm trying to think of the word I always
reflection. Yep. Officially, it's a reflection, but we all know what she means when she says it opens downwards. It makes sense. And then the 1/2, when you're multiplying by number, it's either a vertical stretch, or Natalie used the word shrink. We've also used the word compression. I think the pre-cal book uses shrink more, doesn't it? So, no, it's perfectly fine. It's got the information here. So, let me write down those pieces, and then we'll actually work on the graph. So, let's see. We said there was a vertical shrink by a factor of 1/2. The negative out in front is a reflection across the x-axis. Bless you. And the plus 3 means we were going to translate up 3 units. Right? Okay, so that's just me putting into words all the different pieces we have here. And this is all based on f of x equals x squared. Now, our deal is to graph it. Okay? I actually was just teaching some of the basics about this to Algebra 2 yesterday. And one of the things that might be helpful to remember, if we go, I'm just going to put it right over here, the basic graph, y equals x squared. Do you remember the XY chart I suggested you know / memorize? What's the
you saying that?
Yeah. And if you don't, pick x values of 0, 1, 2 and fill them in. What are the values associated with y equals x squared? 0, 0, 1, 1, and 2, 4. That's your basic parabola there, right? Now we're doing all these other things to it, but that's your basic parabola. Okay, so we want to sketch. Notice this says sketch the graph by hand. So no, that does not mean pull it up on the calculator. The calculator is a good check. I'm not against that. But, knowing how to do this. Trying to decide. Thoughts on how you guys want to go about this? I'm trying to decide where I want to guide you guys. I probably don't have. To an extent, it does matter what you do in what order. Okay? Now, because for instance, we're going to take this graph and we have to move it up 3. Well, as we move it up 3, that changes our y values, doesn't it? So officially, when we do this shrink, we need to do these on the original y values, but we can kind of do that as we go here. So let me put some tick marks on here. I kind of went 4 each direction. And I think what I would suggest, because I just want to draw one parabola in here if you guys can handle that. Where's my new vertex going to be? 0, 3, right? Instead of being at 0, 0, it's going to just go up 3. So there's my new vertex. In a normal parabola, from this point, we would do what? We would go over 1, up 1 both ways, over 2, up 4 both ways. Now, the negatives tells me instead of going up, we're going to go down. So you go over 1, down 1, over 2, down 4. The key is, what about this shrink of 1/2? You remember if it's a vertical shrink or stretch, it affects the, what are my vertical values? Those are the y values. So we're going to talk about the y values. Obviously, it doesn't affect the vertex. Normally, we would go over 1, down 1 in this situation. If we're going to shrink it by 1/2, instead of going over 1, down 1, we're going to go over 1 what? What's half of 1? 1/2. So kind of annoying, but we're going to go over 1, down 1/2. Hard to show on this. We're going to do that on both sides. So over 1, down 1/2. Normally, we would go over 2, down 4. What are we going to do here since there's a shrink of 1/2? Over 2, down 2. Okay, because half of 4 is 2. So I'm going to say over 2, down 2. Over 2, down 2. And that's my best suggestion to doing this graph. Okay? Officially, yes, we have to do the shrink first. But as long as you're using the shrink on your original type setup, I think it works okay to do it this way. Kind of missed that dot there, didn't I? Looks something like that, right? Okay. It's a compression, so it should look a little wider than what I normally draw. Questions on A? Okay, let's try B. H of x is 3 times x plus 2 squared minus 1. Talk to me about the pieces so we can describe the transformations here.
Left 2, down 1.
Okay, we're going to have to translate left 2, down 1. We're comfortable with that, right? And what's the 3 tell me? Stretch by 3, right? So I'm going to write those pieces down. Officially, it is a vertical stretch by a factor of 3. And what do we say? We're going to translate, is my official wording. Left 2 and down 1 unit. Okay. So I'm going to do kind of my setup I did last time. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. I did 4 in each direction. Realize we're going to have to adjust that a little bit. We'll talk about how much we need to adjust it here in a moment. Okay, so what do you know? Where's my vertex have to go? Left 2, down 1. Bless you. That's the easy part, right? Now, a normal shape from there goes over 1, up 1, over 2, up 4. Stretch of 3. Instead of going over 1, up 1, a stretch of 3 means we're going to multiply that y value by 3. So instead of going over 1, up 1, we're going to go over 1, up 3. So I'm going to count over 1, up 1, 2, 3, and over 1, up 3, which because I was 1 below the x-axis, they end up being at a y height of 2, right? And then what about our next one? We're supposed to go over 2, up 4, but the stretch of 3 says we're going to go over 2, up 12. Because the 4 times a stretch of 3 means up 12. So this is going to be a very tall, skinny guy, right? So officially, I'm going to have to make more marks up here, aren't I? I marked up to 11 because since I'm starting from 1 below the x-axis, that would work there. So I'm going to go over 2, which on the right puts me on the y-axis, and up 12. So it puts me up there and about up there. So a very tall, skinny parabola, as you would expect. Very tall, skinny, curvy parabola on my behalf. Okay. That's all technically a review in a way, isn't it? Whether you remember it, whether it all comes together, hopefully all those pieces seem familiar, so it's just putting them together. Okay, ready for the next part? Which I have the next part pulled up on the next page, so I'm going to go ahead and skip to the next page. Vertex form. Okay, I was just teaching this in Algebra 2, so you guys learned this about a year ago. Vertex form of quadratic function or parabola. Any quadratic function, f of x equals ax squared plus bx plus c, which remember, ax squared plus bx plus c, that's your standard form, where a cannot be 0. So if a is 0, it's no longer quadratic, can be written in vertex form. So we're talking about vertex form, which is this f of x or y equals a times x minus h squared plus k. If it's in this form, first of all, the vertex, the whole reason this is called vertex form, folks, your vertex is hk. So recall that your vertex is this number added or subtracted, and then this number that's added or subtracted. Just like when we move left or right, it's opposite the sign in the parentheses, and then we use the sign there at the end. So vertex of hk, axis of symmetry, x equals h. Remember, my axis of symmetry is always the first number from the vertex. Okay? Now, gives us some options here. We can find h using the equation. H equals negative b over 2a. So what this is saying is when it says we can find h, this is what I call, when I taught it to you last year, this is the axis of symmetry formula. Okay? When we learn it in Algebra 2, instead of saying h equals, we say x equals negative b over 2a. I don't care which way you think about it, but we talk about the axis of symmetry being x equals negative b over 2a. The pre-cal book has it being h equals negative b over 2a. But keep in mind, axis of symmetry is x equals h. And then it gives two options here. So there's my axis of symmetry. And then to find the other piece of the vertex. What we did in Algebra 2, I don't know, do you remember? After we found the axis of symmetry, we found our x value, we would plug it back into the original equation to find the y value. And so that is represented right here, where it says k equals f of h. It's them saying that you take what you find, what x value you find, and you put it back into the function. And that gives you your y value. Okay? They also, I've had people on occasion that like this. If you want a formula to use, instead of having to plug back into the original equation, you can use c minus ah squared. So you still have to know the x value, but it's c minus ah squared instead of plugging it back into the equation. That will work equally well too. It's just another formula to know. Okay? I don't care what you do. You guys can play around with it and see what works for you. Okay, one other set of information. If a is greater than 0, we already addressed this earlier, right? Before we talked reflection, right? If a is greater than 0, then the parabola opens upward. If a is less than 0, aka negative, then the parabola opens downward because it's a reflection. That's old news there. So let's look at example 5. Now, this really should say, instead of using, we're not going to use vertex form. We're going to use standard form because that's what they give us here. Okay, we're going to use the standard form of a quadratic function to find the vertex and axis of symmetry of the graph of this given function. And then rewrite the equation in vertex form at the end. Now, how do you guys feel about this function? F of x equals 6x minus 3x squared minus 5. I don't know about you guys. I don't really like it. Could we do something to like it better? Or maybe you guys are okay with it. If you're okay with it, great. If not, my first step is I'm going to rewrite this in order. So I'm going to rewrite this as f of x equals negative 3x squared plus 6x minus 5. Just because I like to be able to easily identify my ABCs and not have to think too hard about it. Okay. So let's start off by finding the axis of symmetry. How do I find the axis of symmetry? We have a formula, yes? If you're in standard form, you have a formula. And that's what we're going to use here. We're going to say, I always say x equals negative b over 2a. If you prefer what they do up above, they say h equals negative b over 2a. So do the math. Negative of, what's b? 6 over 2a, 2 times negative 3. So what do we end up with for our axis of symmetry? Negative 6 over negative 6, which is 1. So my axis of symmetry is x equals 1. Please remember, when you give me axis of symmetry, this is a line, right? This is an equation of a line. So it's x equals a number there. Okay. Then the next question is vertex. What do you already know about your vertex? At this exact moment, I know my vertex is 1 comma something, right? That is, remember, that's no coincidence. My axis of symmetry is always the first number in my vertex. How do I find the second number of the vertex? What?
One of the k equals.
Okay, one of the k equals. If we go back to what I taught in Algebra 2, it's this k equals f of h, which is just saying we take our h value and we put it into the equation. So basically, I'm saying we're going to find f of 1. So that means I'm going to do -3 times 1 squared plus 6 times 1 minus 5. I about changed the problem on us. That would not have been good. So do the math. -3 plus 6 minus 5 gives me -2. And what is that number? It's the second number in the vertex. If you prefer, it's k, right? Your choice. So now we have a vertex of 1, -2. I don't know, did anyone try the other k? Did it work out for you? Okay, and that's your choice, right? Pick and choose. Do you like that other formula, or would you rather just plug it in? It doesn't matter to me. Okay, so we found our axis, we found our vertex. Then it also asked us to rewrite the equation in vertex form. Remember, vertex form is f of x equals a times x minus h squared plus k. So when we write our vertex form, we need to be able to fill in a, h, and k. Do we have all those pieces? We do, whether you realize it or not. What's the one you're maybe questioning? Do we have a? Yeah, what's a? -3. I never wrote them down earlier, but a is -3, b is 6, and c is -5, isn't it? Sorry, I skipped over that. You're pre-cal. I assume you know your ABCs at this point?
I just looked
Okay. Yeah. So this a right here is what we're going to use. Okay, that is the a we're going to use. So write our final answer. F of x equals a, which is -3, x minus what? 1, our axis of symmetry, quantity squared, plus k, I'm going to put -2. Or if you prefer, plus -2, but yeah. Okay. That's technically old news. It's putting it all together. We found axis of symmetry. We found vertex. I taught that last year. I'm teaching it today in Algebra 2, which is why I know you've seen it. It's just a matter of putting it all together. Now, before I go to my next page, note the comment. We can also use completing the square to write quadratic functions in vertex form. It says we learned completing the square in Chapter P. I'm going to say we reviewed completing the square in Chapter P because you learned completing the square back in Algebra 2. Okay? But we relearned it in Chapter P, and guess what? We're going to use it again today. Completing the square does not go away, folks. Ask your calculus friends. It does not go away. it keeps coming back. So it is, you know, if it's one of those things you're like, oh, I'm just not going to learn this skill, you want to learn it. Okay. Example 6. Use completing the square. Okay, so we're not going to use our formulas. We're going to use completing the square. It says to describe the graph of f of x equals 3x squared plus 12x plus 11. It says support graphically to check your answer. Well, support graphically to check your answer, what that's going to be is we can graph our original answer and what we have in vertex form. So we can graph both forms and they should come up the same. Okay? So, do we remember anything about completing the square? No? That's a valid answer. I mean, you know.
It's negative, like, reciprocal. You have to multiply it by 2.
Trying to think.
It's a really weird side step that you have to go out of your way to do.
Okay. Okay.
To add b over 2 squared.
Okay. Yep. And I think that's probably kind of the reciprocal part. Okay. Okay, so first of all, in order to complete the square, okay, we are going to talk about that whole b over 2 squared thing here in a moment, but in order to complete the square, if you were to go back and look at steps in your Algebra 2 notes, the first step, I would say, and this is a different situation because we have f of x on one side, so it is going to make things a little differently, but we're going to need that x squared plus bx by itself. So one of the key things to remember is what has to be in front of x squared? A 1. What do I currently have in front of x squared? A 3. So our first step is going to be factor the 3 out. Now, as I say that our first step is to factor the 3 out, we're only going to factor it out of the x terms. Okay, so if I factor the 3 out of the x terms, 3x squared divided by 3 leaves me with what in parentheses? X squared plus, what if we factor 3 from 12x? What's that leave me with? 4x. Then I'm going to leave a gap before I close my parentheses. And you know that plus 11? We're just going to shift it down outside the parentheses. Because it's not in the parentheses, I don't have to factor a 3 out. And I don't want to try and factor a 3 out then. So it's okay that 11 doesn't divide by 3. Okay, so that first step was just trying to make sure that we have the x squared plus bx by itself. Okay, the next step is you have to find b over 2 quantity squared. What is b in my problem? What is b currently in my problem? 4. Okay, so you're going after you get that 3 factored out. So if my b is 4, that means we're doing what? 4 divided by 2, and then square that, we end up with 4. Okay. What do we normally say? When we're completing the square, we're going to add that 4. And normally we say, if you add 4 on one side of the equation, we add 4 on the other side of the equation. And this is the trick with trying to get to vertex form. I don't really have another side of the equation I can work with, right? This is in function form. So if I add 4 over here to f of x, that's just kind of weird, first of all. But what can I do to compensate if I want to put that 4 over here? If we add 4 here in the parentheses, what do we do here? We don't want to add 4. We want to subtract 4 because we want to keep our equation balanced. And if I add 4 right here, to keep it balanced and not change the value of the equation, I'm going to subtract 4. Now, I have one other little trick though. Is this 4 really a 4? What is this 4? This 4 is being multiplied by 3. So is this 4 really just a 4? No. So we added 4 here. Well, really we're adding a value of 12, which means over here when we subtract 4, we want to subtract 4 times 3. In other words, we want to subtract a value of 12. Okay, so if we add 4 here, we're going to subtract 4 here. Because we had a GCF we factored out, we're multiplying by that 3. Okay. We're ready to rewrite this in vertex form. So f of x stays f of x. 3 stays 3. If you recall from completing the square, after you complete the square, my job is always to factor. X squared plus 4x plus 4. Officially, it factors into 2 parentheses, right? X squared breaks into x in one parenthesis, x in the other parenthesis, right? You could ask yourself what multiplies before and adds to before. And what are those numbers? 2 times 2, right? Or really what we're doing is, what's the square root of 4? The square root of 4 is 2. Use the sign of the same sign from the middle sign, so it's plus 4x, so we're going to say plus 2. And at the end, you're just cleaning it up. So we have 11 minus 4 times 3. 11 minus 12 is minus 1.
Wait, would you want to use PEMDAS on the last one?
Yes, so 4 times 3
Okay.
is 12, and then 11 minus 12 is negative 1.
Okay, I just heard you say 11 minus 4 times that threw me off.
Yeah, when I said that, I was just reading 11 minus 4 times 3, but definitely yes, order of operations, please. Okay, guys, so this is vertex form. Okay, that is your vertex form right there. What can you tell me about this? It has a vertex where? Where's that vertex at?
-2.
-2, -1. And it has a stretch of 3, right? Okay, the whole confirmed graphically. Ew. Sorry. Dead fly on my desk. Not a big fan of. Okay, so if I graph the original, which was 3x squared plus 12x plus 11. And then if I graph my vertex form, 3 parentheses, x plus 2, 20 squared minus 1. The idea of confirming graphically is that these two graphs should be the same. And if they're not, we did something wrong. Here's my first graph. There's my second graph tracing it. Okay, so that's my confirm graphically there. Okay, so in order to confirm graphically, my recommendation, it's not something you have to do, but it doesn't hurt, is to graph original and new equations as a check. Okay. Yes? Is your stat plot still on from yesterday?
I took that off, but now it's saying it's like a window.
Okay, so my easy, looks like it should be good. My easy, do a zoom 6. Because that's saying your stat plot's not on. So do a 1 quick to get out of there. And then, yeah, it's showing that first one is still on. So if you enter into that, and then hit enter, now it should be on. And now it likes you. Okay, you're welcome. Yes, the stat, I don't understand, because sometimes these calculators will graph perfectly fine with stat plot on. Other times, not at all. And I can never understand. Yes, they've graphed and our stat plots were on. Today, it doesn't want to. So, okay. One last example. Got just the right amount of time, I hope. Example 7. Given a vertex of negative 3, 5, and a point of 2, 1, write the equation for the quadratic function. I taught this yesterday in Algebra 2, guys. Which means it's not new. Okay, it's just a matter of remembering it. So, if we are given a vertex of negative 3, 5, what are negative 3 and 5 then? H and K. Okay, and then a point of 2, 1. Well, a point, an ordered pair, is always represented as what? X and Y. Write the equation for the quadratic function. Well, when they give you the vertex, we need to talk vertex form. So we're talking, let's see, I started to use f of x. Oh well. F of x equals a times x minus h squared plus k. In order to write this, we need to know a, h, and k. We know h and k, yes. The trick is we don't know a. And so our job here is to find a. So as we think about this, first of all, remember f of x is another way of saying y, right? So if you think about what we know, we don't know a yet, do we? But we know x minus, my h is going to be negative 3. So I'm going to say x plus 3, quantity squared, plus k, so plus 5. That's what we have. Do we have information that will help us find a? Because that's the trick, is we don't know a. Do we have information that will help us find a? Yeah, we have this xy point here we can use. And that's what we want to use. We want to fill that in and use that to find a. So for y, I'm going to say 1 equals a times x plus 3. So 2 plus 3 squared plus 5. Order of operations. You guys say PEMDAS. I talk about my Aunt Sally. So 2 plus 3 is 5. 5 squared is 25. Now note, don't go on and do 25 plus 5. What is this 25 attached to? That's 25a plus 5, and it still equals 1. So that's the trick right there, is don't go on and say, oh, that's 30a. No, it's 25 times a plus a 5. So if it's 25a plus 5, we're going to subtract 5. 1 minus 5 is negative 4 equals 25a. And so then if I solve, divide by 25, and a is Negative 4 divided by 25. Not pretty, but it gives me what I need, doesn't it? And I don't have to do anything else with it. So it can be a negative fraction. Because we're ready to write the equation now. Okay. You can say f of x or y, I'm not picky either way, equals, what's a? Negative 4 25ths, parentheses, x minus h, so that is that x minus negative 3, quantity squared, plus k, plus 5. Okay? Does that process sound at all familiar to you? Maybe a little? So, now you can help your Algebra 2 friends when they're struggling? No? I've refreshed your memory, so it always works out nicely when we talk about quadratics at the same time. Okay, the homework that goes along with this page is on page 169, 13 through 18 all, 24 through 44 evens. Watch the directions, okay? A lot of them go with the stuff we're doing. I did have a note in my lesson plans. What did it say? Okay, it says 13 through 18, and the note is something about watching the vertical scale. So I think when you look at 13 through 18, you're looking at graphs. And yeah, kind of watch. Okay, the vertical scales on 13 through 18 count by 5s. It doesn't tell you that anywhere. You just kind of have to figure it out. So just kind of make a mental note that the vertical scales count by 5s, and it'll make more sense when because you're just trying to match equations with graphs there. Okay? Have this along with the original assignment all finished for tomorrow, and we will probably spend tomorrow going over questions. Okay?